The universe begins in silence, an unsettling, absolute kind of silence that presses against the human mind like a weight. Imagine drifting through a cosmic ocean where even light seems hesitant to move, where distant galaxies appear as faint scars across an endless void. In that stillness, every instinct in the human body whispers the same thing. Something is watching. Something is waiting. Something is hidden. The vastness is supposed to comfort us. We're told that space is simply big, empty, indifferent. But the deeper we look, the clearer it becomes that this emptiness is not passive. It behaves like a curtain, thin, shimmering, and deliberate, concealing truths that feel intentionally out of reach. Behind that curtain, the universe holds phenomena so disturbing, so profoundly alien, that they defy every law we've written in our scientific textbooks. Yet they remain just far enough away, just faint enough, to leave us doubting ourselves. Humans are not built for such uncertainty. When a shadow moves at the corner of our vision, our instincts ignite with ancient fear. We search for shape, pattern, meaning. We hunt for the source of the unknown. But space doesn't reward that impulse. Mocks it. It is a labyrinth of partial clues and half-answered questions where each discovery opens a darker doorway behind it. The more we learn, the more we understand how little we can truly grasp, and how much the universe refuses to reveal. Imagine floating through a region of space where the starlight dims unnaturally, as if being absorbed by an invisible film. Sensors fail without explanation. Radiation spikes with no source. The very fabric of spacetime feels distorted, stretched thin like worn cloth. Scientists label moments like these as anomalies, temporary, rare, unexplained. But anomalies repeat. Patterns return. The same disturbances emerge in places separated by billions of light years, as though the cosmos itself is hinting at something vast and troubling just beneath the surface. Yet these hints are inconsistent, fragmented, eerily incomplete. It's as if the universe is revealing its secrets with the same caution a predator uses while circling prey in the dark. You feel its presence but you never see the shape. You only sense the intention. This tension, this dance between revelation and concealment, has defined our entire relationship with the cosmos. Telescopes grow more powerful, detectors more sensitive, equations more complex, and still the deepest mysteries remain as elusive as ever. It's as though the universe is structured not only to challenge us but to restrict us, holding back its most disturbing truths with a precision that feels almost intelligent. Scientists often describe the universe as strange but not malicious. Yet there are moments, rare, quiet moments, when the data tells a different story. Moments when an unexplained signal appears and vanishes, never to be recorded again. Moments when a measurement contradicts every known theory, only to realign perfectly seconds later. Moments when an entire region of space behaves like a locked room, hiding its contents behind laws of physics that simply should not break, but do. Why does the universe tease us with these glimpses? Why does it offer a whisper of truth only to erase it the moment we turn our heads? Perhaps the better question is, what would happen if it didn't? If every hidden phenomenon were suddenly exposed in full, the result might not be enlightenment, it might be psychological collapse. Humanity struggles with mysteries at the scale of the ocean, the deep jungle, the desert night. What happens when the mysteries operate at the scale of galaxies, spanning billions of years, using forces that bend light and rewrite space? Our minds were not evolved to comprehend such enormity. Our tools were not built to measure such strangeness. And yet the urge to know persists. That primal curiosity is our species' greatest strength and greatest vulnerability. It pulls us closer to the dark, whispering that knowledge is power, even when the unknown is capable of destroying us. Picture a lone spacecraft drifting through a region of space rarely mapped by telescopes. At first, everything is normal. Background radiation hums at expected levels, starlight moves predictably, gravitational fields remain steady. Then, slowly the readings begin to shift. Not dramatically, subtly. A fraction of a percentage here, a slight drift there. The crew brushes it off as sensor drift. But the drift continues. Patterns emerge in the noise. Rhythmic pulses appear in the radiation field. Temperature variations move in waves, almost like breath. Something in the void is stirring. But when the ship attempts to record the anomaly, the data corrupts. Logs scramble. Instruments freeze. The disturbance vanishes, leaving behind only confusion and a crushing sense of dread. What did the sensors detect? What was trying to reveal itself? And why did it retreat the moment it was noticed? These scenarios are not fiction. They are composites of real observations, real anomalies, real events that astronomers and physicists cannot fully explain. Some are buried in technical documents. Others are quietly dismissed as equipment failure. But they accumulate, forming a shadow archive of cosmic phenomena that feel less like natural irregularities and more like warnings. Maybe the universe isn't silent. Maybe it's whispering. Whispering things we're not ready to hear. And this raises a chilling possibility. What if the universe is not indifferent to our presence? What if the emptiness is not empty at all, but a theater of hidden mechanisms shaping reality from behind the scenes? Mechanisms that allow just enough clarity for us to survive, but not enough to understand the true forces at work. As we drift deeper into the unknown, crossing boundaries that no life form has crossed before, one question hangs heavier than all others. A question that grows darker each time we uncover a new cosmic anomaly. What does the universe gain by keeping its most disturbing phenomena hidden? At the farthest limits of human perception lies a boundary so distant, so unreachable, that it behaves less like a physical horizon and more like a warning line. This edge, the observable limit of the universe, marks the final frontier of what our telescopes, satellites, and equations can ever reveal. Beyond it stretches a darkness that has never been touched by human eyes, a realm where light has not yet arrived, where information has not yet traveled, and where the most disturbing cosmic phenomena may be hiding in plain sight. To understand this boundary, imagine standing on the shoreline of an infinite ocean at night. You can see the waves breaking at your feet, you can hear the water shifting just beyond reach, but past a certain point, everything fades to black. You know the ocean continues endlessly into the dark, but you cannot see where it goes, what creatures swim beneath its waters, or what storms it might be hiding. The universe is the same. We see only the illuminated portion, just 4% of the cosmic expanse. The rest lies beyond the faint glow of ancient starlight, beyond the reach of every instrument we possess. This edge is not a wall. It is not a barrier constructed by physics. It is simply the point beyond which light has not had enough time to reach us. The universe is expanding faster than photons can travel, stretching space so aggressively that distant galaxies are fleeing from us at speeds that break intuition. Anything beyond that limit is erased, not because it doesn't exist, but because the cosmos is pulling it away faster than reality can reveal itself to us. And that raises a chilling thought. What if the universe has arranged itself so that its most unsettling truths remain forever out of view? The observable edge shimmers like a cosmic mirage. Galaxies there appear distorted, stretched, and smeared across the sky like paint dragged across glass. Some flicker with impossible brightness. Others vanish unexpectedly as if swallowed by an unseen force. Their light has traveled for more than 13 billion years, crossing through shifting gravitational currents, cosmic storms, and pockets of warped spacetime. By the time it reaches us, that light carries scars, marks of invisible interactions. Clues. Warnings. Imagine a field of galaxies arranged near the horizon of what we can observe, tiny distant specks trembling at the edge of existence. They behave strangely. Their shapes twist. Their movements defy the standard rules. Some seem to accelerate unnaturally, as though pulled by a hidden mass that does not appear on any map. Others flicker in synchronized patterns, as if responding to a force we cannot detect. Scientists call these distortions lensing effects, measurement noise, or observational limitations. But the distortions repeat. They form patterns. And they create the unsettling impression that something is happening just beyond our reach. Something with structure, intention, or scale far beyond human comprehension. Now imagine drifting past this boundary, not physically but mentally, through speculation and mathematics. Past the horizon, physics may break. Time may move differently. Entire clusters of matter could behave in ways no human theory can predict. There could be regions where the laws of nature shift spontaneously, where gravity weakens or strengthens without cause, where particles behave like shapes in a dream, flickering between states that defy logic. What if entire civilizations exist beyond our horizon, living in zones where time flows faster or slower, where stars form differently, where matter assembles in unfamiliar ways? Their light would never reach us. Their signals would never arrive. They could be billions of years advanced, or long extinct, completely inaccessible, entirely unreachable, forever hidden by the universe's expanding boundary. And yet, occasionally, faint hints drift inward. Strange temperature variations in the cosmic microwave background. Unexplained cold spots. Regions of space where the geometry seems subtly twisted, as if pressed against by something massive just outside our field of view. These distortions could be nothing, or they could be shadows of titanic structures beyond the horizon. Perhaps colossal clusters of matter so immense they warp not just light but the fabric of existence itself. Or stranger things, cosmic walls, voids, or phenomena that obey rules we have not yet imagined. The idea that the universe might deliberately conceal these things is unsettling. But the concealment is real. No matter how advanced we become, no telescope, no probe, no mathematical breakthrough can ever reveal what lies past this limit. Physics itself forbids it. The expansion of space ensures that the universe keeps its most distant regions locked away, inaccessible forever. Does this boundary exist merely as a natural consequence of cosmic expansion, or is it part of a deeper architecture? Some theorists whisper about a cosmic isolation protocol, a self-enforcing mechanism that ensures each region of the universe develops in isolation, protected from, or trapped away from, others. They speculate about multiverse membranes brushing against our universe. They question whether the horizon is not merely a distance but a threshold, a dimensional shift where reality transforms into something unrecognizable. Others consider a more unsettling idea. What if something beyond the horizon has already begun to cross it? Signals that fluctuate without explanation. Temperature anomalies that persist in patterns. Gravitational waves that appear and vanish as though intentionally concealed. These signatures leave behind a haunting possibility that whatever lies beyond the observable edge may not be static. It may be approaching, slowly, quietly, unnoticed by most, but detectable in subtle ways if one knows how to look. Imagine a force so vast that it bends entire regions of space from the outside. A phenomenon so large we can only detect its shadow. A presence pushing into our universe like a rising tide. We cannot see it. We cannot measure it. But we can feel its effects. The cosmic horizon is not merely a boundary of sight. It is a boundary of safety. Beyond it may lie regions where galaxies collide endlessly, where black holes consume not just matter but laws of physics, where dimensions fold into each other like collapsing paper. Or perhaps there are universes brushing against ours, vast, luminous, or monstrous, tilting the geometry of our cosmos from the outside. And through these possibilities runs one lingering, unsettling question. Is the universe expanding simply because it's growing, or because something beyond the horizon is forcing it to make room? The deeper we peer into the distant dark, the more we sense a presence we cannot name. A feeling of tension at the cosmic edge like fabric pulled too tight. A whisper of something vast pressing against the visible universe, waiting to reveal itself, or to remain forever hidden. Something is there. Something just beyond the observable edge. The night sky has always been a source of wonder, but beneath its beauty lies a silence so absolute, so total, that it has begun to unsettle even the most rational minds. When we look up, we expect to find signs of life, signals, patterns, technological whispers from civilizations that should, by all probability, exist. Instead we find nothing. Not a single confirmed transmission. Not a single echo of intelligence. Just an endless void, humming with ancient starlight and unanswered questions. This silence is not normal. It is not what the laws of probability predict. In a universe with trillions of stars and countless planets, life should not just be possible, it should be everywhere. It should be flourishing, echoing across space in waves of communication, exploration, and cosmic ambition. And yet all we find is emptiness. This emptiness is not passive. It feels intentional, like a quiet set so meticulously arranged that even the smallest sound seems forbidden. The farther we look, the deeper the silence grows, expanding like a cold fog swallowing distant worlds. It is a silence so heavy that it becomes its own kind of evidence. Evidence that something has happened out there, something that erased the voices we expected to find. Imagine drifting through a star system that once glowed bright with possibility. At its center, a sun burns fiercely, throwing streams of light into the darkness. But orbiting it are only barren planets, worlds of cracked stone, frozen seas, and dead atmospheres. These are not planets waiting to evolve. They feel like planets that have already lived, already died, and left behind nothing but ruins wiped clean by time or something far more deliberate. Again and again, as our telescopes gaze deeper into the cosmos, we find worlds that look like tombstones, silent reminders of civilizations that never appear. It raises a terrifying question. Are we alone because no one else has ever existed, or because something has made sure they no longer do? The universe is old, older than humanity can truly grasp. In those vast stretches of time, entire galactic empires could have risen and fallen long before Earth formed. And yet no trace remains. No megastructures. No signals. No cosmic engineering. Nothing. It is as if the universe has been scrubbed clean of intelligent life. Scientists call this contradiction the Great Silence, but the phrase barely captures the weight of the mystery. To understand the scale, Imagine a forest teeming with millions of species. Now imagine walking through that forest and hearing absolutely nothing. Not a bird call, not an insect buzz, not a rustle of leaves. Only stillness. Such a silence would not suggest a healthy forest. It would suggest a forest where something terrible has happened, something that wiped out every living creature. Now apply that silence to the universe. Some theorists propose that civilizations might be hiding, deliberately. That they fear something greater, something predatory that watches for technological noise like a hunter listening for movement in the dark. In this scenario, silence becomes a survival strategy. Broadcast nothing. Reveal nothing. Stay invisible. Stay alive. If this is true, then humanity, with its radio waves spilling into space like a beacon, may be one of the few species foolish enough to shout into the void. But perhaps the silence is not fear. Perhaps it is aftermath. There are regions of the universe where galaxies appear dimmer than expected, where stars seem to die unnaturally young. Some astronomers whisper about cosmic graveyards, areas of space where something catastrophic may have occurred on a scale beyond comprehension. These zones do not behave normally. They are colder, emptier, strangely uniform, as if something has stripped them of complexity. If advanced civilizations once lived there, their remains are long gone. It is possible, some argue, that the universe undergoes periodic resets, vast cosmic events that wipe the slate clean. Gamma-ray bursts, rogue black holes, vacuum instability events, any of these could sterilize huge portions of the cosmos without warning. If such catastrophes occur often enough across billions of years, then life might continuously restart, struggling again and again to gain a foothold before the next annihilation arrives. In that case, the great silence is not surprising. It is inevitable. But the silence feels too precise, too uniform, too perfectly maintained to be explained entirely by chance or catastrophe. There is a pattern to it, a consistency that suggests a deeper mechanism at work. It is as though the universe maintains a threshold, an invisible limit on how far life can spread before something intervenes. This cosmic filter could be anything: a fundamental physical barrier, a mysterious biological constraint, a phenomenon we have not yet discovered, or something far more intentional. Some scientists have analyzed the distribution of stars, planets, and cosmic structures and found eerie alignments, subtle patterns that hint at large-scale order beneath the randomness. Such patterns raise disturbing possibilities. What if the universe is not simply empty, but structured to remain silent? What if intelligence, once it reaches a certain level, triggers events that ensure its own extinction? Imagine a world that develops faster than others. Its inhabitants construct machines, harness energy, build cities, explore the stars. Then, suddenly, without warning, something occurs. A burst of radiation. A collapse of spacetime. A sudden shift in physical constants. The entire civilization vanishes, leaving behind no evidence it ever existed. Not because it destroyed itself, but because the universe enforced silence. This idea is terrifying not because it implies danger, but because it implies inevitability. Yet the silence continues to expand. With every new survey of the cosmos, we expect to find a breakthrough, a signal, a structure, a hint of alien engineering. But the void remains flawless, clean, undisturbed. Even the exoplanets most similar to Earth show no signs of life beyond microbial possibility. Vast stretches of space feel untouched, as if intelligence never had the chance to bloom. And so we are left with a haunting contrast, a universe bursting with potential but empty of voices. A cosmic theater with countless stages yet no actors. A silence so perfect that it feels unnatural. What if the universe is not silent because life is rare? What if it is silent because something has silenced it? This possibility grows more unsettling when we consider the one faint anomaly that keeps repeating, brief, unexplained signals that appear once, then vanish forever. They never repeat, never confirm themselves, never provide enough data for identification. They behave like something testing the boundaries of detection, like a presence tapping lightly on the cosmic window, checking if anyone is listening. But the signals stop before we can respond, almost as if they didn't want us to. This leaves us with a final chilling question, one that hangs over the cosmos like a shadow. What erased the voices of the universe, and how long before it notices ours? Imagine standing inside a vast cathedral where every column, every arch, every beam of support is completely invisible. You feel the weight of the structure around you, you feel the pressure of its presence, and you know the architecture must exist, yet your eyes register nothing. That is the unsettling nature of dark matter. It holds the universe together, it shapes galaxies, it binds the cosmic web, yet it hides itself with a perfection that defies imagination. It is the greatest unseen force in existence, a silent grip that governs everything while revealing nothing. When scientists first discovered dark matter, they didn't see it. They felt it, through motion, imbalance, and contradiction. Galaxies were spinning too fast. Stars at the edges should have flung themselves into the void, scattered like sparks from a dying fire. But they didn't. Something held them tightly, something powerful and invisible. It was as though a massive hidden hand was cupping each galaxy, preventing it from tearing itself apart. That invisible hand has only grown more disturbing with every observation. Picture a spiral galaxy, rotating serenely like a cosmic whirlpool. The luminous arms glow with millions of stars, but around it, extending far beyond its visible edge, lies a vast halo of dark matter. No light shines from it. No radiation escapes it. Yet it exerts immense gravitational force, enough to anchor the galaxy and sculpt its shape for billions of years. Every galaxy we look at is wrapped in this invisible cloak, every cluster bound by unseen tethers. The universe is not made of what we can see. It is made of the darkness between. And this darkness behaves like nothing we have ever encountered. When galaxies collide, their stars pass through each other untouched, like ghosts drifting through a fog. But dark matter reacts differently. It clumps, it drags, it distorts the very shape of spacetime. It creates gravitational fingerprints we can detect only through careful measurement and eerie distortions in the light of distant galaxies. These distortions, cosmic lensing, reveal vast structures made of dark matter, towering formations that surround and sculpt the universe. Yet we still have no idea what dark matter actually is. It could be particles, but we haven't found them. It could be a field, but we haven't measured it. It could be an entire shadow universe operating alongside ours, invisible and untouchable but undeniably real. The truth is that we do not know what form it takes, what rules it follows, or why it interacts so selectively with the world we inhabit. Some scientists describe dark matter as a ghost, ever-present, ever-influential, but forever beyond reach. Others compare it to a puppet master, pulling strings behind the scenes, directing the motion of galaxies while refusing to show its face. But those are metaphors born of discomfort, not understanding. The reality may be far stranger. Imagine a force so subtle that it never collides with atoms, never touches light, never interacts with anything except gravity itself. That means it passes through planets, stars, entire galaxies without slowing down or dispersing. Right now, dark matter is streaming through your body, through the earth, through the air, through everything you've ever known, and you cannot feel it. It is everywhere. It is everything. And it is invisible. The deepest mystery is not how powerful dark matter is, but how quiet. If it were simply another form of matter, we should have found it by now. Our detectors are sensitive enough to pick up a single particle of light bouncing off a mirror. They can detect traces of radiation thousands of light years away. And yet dark matter leaves no mark. No signal. No footprint. It refuses to reveal itself. This refusal raises an unsettling possibility. What if dark matter isn't matter at all? What if it's the effect of something deeper, something hidden beneath the fabric of reality? Some physicists suspect dark matter may be a sign of undiscovered dimensions. In this interpretation, the gravitational pull we feel is not coming from particles, but from mass leaking into our universe from realms we cannot access. Others argue that dark matter might be the residue of ancient cosmic events, echoes of previous universes, fractures where physical laws overlap. And then there are the darker theories. A growing number of researchers wonder if dark matter behaves like a network, a vast, interconnected framework guiding the flow of galaxies. In simulations, dark matter forms webs, branches, and nodes, almost like the neural pathways of a brain. These structures span millions of light years, shaping everything from star formation to galaxy rotation. When we map dark matter, the universe resembles something alive. This resemblance is unsettling. The cosmic web looks less like a random scatter of matter and more like a designed scaffolding. A skeleton. A blueprint. An architecture of something immense, something that may not be passive at all. What if dark matter is not simply holding galaxies together? What if it is directing them? There are anomalies that support this chilling idea. In certain galaxy clusters, dark matter seems to move independently of ordinary matter. In others, it behaves as though responding to forces we cannot detect. There are even regions where dark matter appears to clump in patterns that no known physics can explain, as though following rules written in a hidden layer of the universe. And then there is the most disturbing phenomenon of all. Dark matter doesn't just pull. It sometimes pushes. We have observed galaxies where dark matter seems to create repulsive zones, regions where stars are strangely absent, where matter refuses to gather. These voids act like barriers, unnatural gaps in the cosmic landscape. They do not behave like areas of low density. They behave like places where something actively prevents matter from entering. If dark matter can attract and repel, it becomes not just a structure but a force capable of shaping the development of galaxies, star systems, perhaps even life itself. Now imagine what this means for humanity. Every human story, every civilization, every moment in the history of Earth occurred inside a dark matter halo, an invisible cocoon larger than the Milky Way itself. Everything we have ever known is suspended in this unseen grip. We are children of a force we cannot understand, living inside an invisible architecture that may have existed long before atoms formed. Some physicists believe dark matter may contain its own forms of structure. Dark stars, dark planets, even dark galaxies made of materials that pass through us as if we do not exist. These shadow structures might be as complex and ancient as the visible universe. Entire worlds could be orbiting in the darkness, untouchable and unknown, sharing space with us without ever revealing their presence. And if such structures exist, then life, in some unimaginable form, might exist there too. Invisible civilizations. Silent networks of dark matter engineering. Patterns of intelligence woven into the gravitational fabric of the cosmos. Life that does not need light, atoms, or ordinary matter. Life that evolved in a realm we cannot perceive. If dark matter holds such secrets, then it is not merely a component of the universe. It is the universe. And we, fragile beings made of ordinary matter, are not the main players in this cosmic story. We may be a rare anomaly, a flicker of visibility in a world dominated by the unseen. The universe may not revolve around the galaxies we observe. It may revolve around the vast, silent architecture of dark matter, shaping everything from behind the veil. The deeper we study this hidden force, the clearer one truth becomes. Dark matter is not a passive background. It is an active presence. A dominant, invisible framework that holds the cosmos in its grip while refusing to show its true nature. And until we understand what dark matter really is, we will never truly understand the universe, or our place within it. Something is pulling the strings. Something unseen. Something powerful. Something that might not want to be found. The universe, when mapped on its largest scales, does not look like scattered stars tossed randomly into the void. Instead, it resembles a colossal web, a vast network of filaments stretching across billions of light years, weaving galaxies together in patterns that seem almost biological. These filaments glow faintly with clusters of galaxies, while between them lie enormous cavities of darkness known as cosmic voids. Together, they create a structure so immense and intricate that it feels less like a natural arrangement and more like the architecture of something ancient and deliberate. From a distance, the cosmic web appears peaceful, a delicate lattice of gossamer threads holding the universe in balance. But up close, within the hidden corridors of these filaments, the picture changes. Gravity shifts unpredictably. Radiation pulses in irregular patterns. Matter moves as though guided by unseen currents. The web is not passive. It shapes galaxies, influences cosmic flows, and channels matter along predetermined routes. Routes that resemble pathways like trails worn into the fabric of existence. Imagine drifting through one of these filaments, surrounded by the faint glow of trillions of stars. Space is not empty here. It is dense, layered, restless. Invisible walls of dark matter press in from all sides, creating a cage of gravitational force that bends the motion of entire galaxy clusters. These filaments behave like cosmic highways, funneling matter along lanes that have existed since the dawn of time. Everything in the universe, galaxies, gas clouds, dark matter, moves along these routes as if following instructions imprinted into the fabric of reality. But these pathways have strange features. At certain crossing points, the gravitational fields behave erratically, stretching and twisting in ways that defy standard models. Some regions experience abrupt increases in density, like knots tied into the web. Others form unnatural gaps, as though something has carved tunnels through the filament. The forces at play are complex, layered with unknown interactions. It is as if the universe is performing a task we cannot interpret, manipulating its structure with precision for reasons we do not understand. In many places, the cosmic web acts almost like a trap. Matter flows towards certain nodes, gravitational hubs, but once inside it becomes difficult to escape. These hubs pull in galaxies, gas, dust, and dark matter alike, creating immense superclusters held together not just by gravity, but by something more elusive, Some simulations suggest forces within these nodes behave unpredictably, as though they are influenced by fluctuations from deeper layers of the universe. It is possible that these nodes act as amplifiers, concentrating energy and shaping cosmic evolution in ways we have barely begun to understand. The voids between filaments are even stranger. These vast, yawning bubbles of near-perfect emptiness seem unnaturally uniform, too round, too consistent, too neatly carved. They expand faster than the surrounding filaments, pushing against the cosmic web with a quiet but relentless pressure. Some astronomers suspect that these voids aren't simply empty regions, but areas where exotic forces dominate, forces that repel matter or distort spacetime in ways we cannot detect directly. In the deepest voids, galaxies behave oddly. They drift faster as if pushed by invisible winds. Their shapes warp subtly. Their rotations slow or accelerate without explanation. It is as though these voids contain phenomena that do not interact with light or gravity in familiar ways, like pockets of alternate physics hidden within the cosmic landscape. This raises a chilling possibility. What if the cosmic web is not merely a structure but a boundary? What if the filaments are the walls that separate our universe from something else, something the voids are slowly revealing? Some theorists propose that the web acts like a containment field, preventing large-scale disturbances from spreading. Others believe the web channels energy from unknown cosmic processes, acting as a distribution network for forces that originate beyond our observable universe. In this view, the filaments are not natural outcomes of cosmic evolution. They are conduits, and what they carry may not be benign. There are regions where the web appears torn or fractured, areas where the gravitational structure collapses into chaotic patterns. These anomalies behave like wounds, places where the cosmic fabric has been damaged or pierced. Light passing through these regions bends unpredictably, like reflections in a shattered mirror. Some scientists speculate these fractures could be points where the boundary between universes thins, allowing exotic energies to seep through. Even more disturbing are the filaments that appear to move. Recent observations have shown subtle shifts in their positions, like the slow, grinding movement of tectonic plates. These shifts are so gradual that only long-term measurements reveal them. But they are real. The web is sliding, stretching, reconfiguring itself over billions of years, almost as though it is alive, responding to pressures we cannot detect. If the cosmic web is evolving, then the universe's hidden architecture is not static. It is dynamic, intentional. It behaves like a system adjusting itself, maintaining equilibrium or preparing for something yet to come. This realization forces a disturbing question. Are we witnessing the natural behavior of cosmic structure, or are we observing the signature of an intelligence so vast and ancient that it operates on scales beyond comprehension? If an intelligence exists within the cosmic web, it would not communicate through light or sound or electromagnetic signals. It would speak through gravity, through structure, through the reshaping of spacetime. Its messages would be written in the arrangement of galaxies. Its intentions would be encoded in the tension of filaments. Its presence would be detectable only as subtle distortions in the cosmic web, distortions we have already started to observe. Perhaps the web is not merely a map of the universe. Perhaps it is a message, or a mechanism. A structure designed not just to hold matter together, but to control how the universe evolves, guiding the formation of galaxies, regulating the flow of energy, stabilizing cosmic expansion, or preparing the universe for something waiting in the voids. If this is true, then humanity is living inside a system far more intricate and far more deliberate than anything we have imagined. We are not just drifting through random space. We are moving through a vast framework whose function remains hidden, whose rules remain unspoken, and whose full purpose may be something the universe is not yet ready to reveal. Something in the cosmic web is shaping us, directing us, trapping us, and whatever lies within those hidden pathways may not want to be discovered. Time is supposed to be constant, a quiet river flowing uniformly from past to present to future. It is the one dimension humans instinctively trust, the invisible thread that stitches every moment of existence together. But the deeper we peer into the cosmos, the more unstable that thread becomes. Time is not rigid. Time is not reliable. And in the darkest, most distant corners of the universe, time begins to behave like something alive, stretching, bending, flickering, and in some places, vanishing altogether. Imagine drifting toward a region of space where time begins to slow, like a heartbeat losing rhythm. Clocks stop agreeing with one another. Light itself hesitates, crawling at a pace that feels unnatural. It's as though the universe becomes unsure of how fast it wants to move. These anomalies are not illusions. They are real, measurable distortions, hints that time is not a universal law, but a fragile layer of reality that can warp without warning. Scientists call these distortions gravitational time dilation, but the term barely captures the unsettling nature of what's happening. Near black holes, time stretches like taffy. In regions with intense cosmic energy, time accelerates. And in vast cosmic voids, those enormous silent gaps between the filaments of the universe, time behaves in ways we cannot yet explain. It drifts. It fluctuates. It thins. It's as if the universe is erasing its own footprints, letting time dissolve in pockets so empty that even seconds struggle to exist. Consider a distant galaxy cluster, shimmering faintly at the edge of observation. When astronomers measure the light coming from multiple points within the cluster, they find discrepancies, tiny but undeniable. Events that should be simultaneous are not. Bursts of radiation arrive earlier than expected. Stellar rotations appear slightly out of sync. Something in that region is disrupting the flow of time, bending it into shapes that make no logical sense. Some of these distortions are subtle. Others are violent. There are reports of stars aging faster than the galaxies surrounding them. Entire regions where time appears compressed, as though billions of years have passed in the blink of a cosmic eye. These zones act like temporal whirlpools, accelerating or slowing the flow of existence with no clear cause. When simulations attempt to replicate these effects, they fail. The formulas break. The calculations spiral into impossibility. It is as if the universe is doing something behind the scenes that we are not meant to understand. And then there are the voids, those vast, haunting expanses where galaxies are almost completely absent. Time behaves strangely within them. It flows more smoothly, more quietly, lacking the gravitational tug-of-war created by dense cosmic structures. Some theories suggest time is faster inside voids. Others propose the opposite, that time stagnates there, moving so slowly that change becomes nearly impossible. But the most chilling hypothesis is that time inside these voids is beginning to unravel. Imagine entering a region where the laws of physics feel less anchored, where the fabric of spacetime becomes thin enough to ripple. In such places, events may not follow sequence. Effects may occur before causes. Light could drift unpredictably, like a ghost searching for a timeline to belong to. Time could fold, creating loops and eddies that trap energy, motion, even entire star systems in repeating cycles. If these temporal scars exist, they may be remnants of ancient cosmic events. Collisions between dimensions, interactions with unknown forces, or ruptures where the boundaries of our universe were briefly torn open. But there is another possibility, far more unsettling. Time may not be stable across the cosmos because the universe itself is evolving in ways we cannot detect. Some physicists suspect time is weakening, stretching thinner across expanding space. As the universe grows faster and faster, the timeline holding it together may be fraying, like an overextended fabric. If true, then distant regions may already be experiencing early signs of temporal decay, moments slipping out of sequence, events occurring with incomplete causality, patches of existence operating on corrupted clocks. Even light, the universe's fastest messenger, could become confused. Photons traveling through these distorted zones might arrive earlier or later than expected, carrying signatures that contradict known physics. We may already be detecting such signals, we simply haven't recognized them as warnings. Imagine receiving a pulse of radiation from a dying star, only to realize the star itself is still intact. Or observing an explosion that seems to repeat every few years, as if trapped in a loop of its own demise. These are not hypothetical scenarios. They are real anomalies buried in astronomical data, dismissed, debated, or quietly filed away because they don't fit existing theory. What if they are signs that time in certain regions has become unstable? In some rare cases, time doesn't just distort. It vanishes. At the horizons of black holes, at the edges of cosmic strings, near hypothetical defects in spacetime, time breaks down completely. It becomes meaningless, directionless, chaotic. Past and future lose distinction. Only the present remains, a frozen, impossible moment stretched across infinity. If such regions exist on smaller scales throughout the cosmos, then they could be acting like temporal sinkholes, sucking time inward, disrupting surrounding space. These zones might drift slowly across the universe, leaving trails of warped causality behind them. Their movement would be undetectable, but their effects could shape galactic behavior, distort orbits, warp light patterns, and create phenomena that appear supernatural only because they are unfamiliar. Even more disturbing is the idea that time may not be a constant feature of the universe at all, that it emerged only after certain cosmic conditions were met, and could disappear if those conditions change. If dark energy continues to rip the universe apart at accelerating speeds, time itself may stretch so thin that it no longer flows. Existence would slow. Motion would cease. The universe could freeze into a static, eternal moment. But what if some regions are already experiencing early versions of this? What if patches of the cosmos are falling out of time, slipping into silence where history no longer unfolds? Imagine a galaxy looking perfectly normal, glowing softly in the dark, but inside it, nothing is happening. Stars aren't burning. Planets aren't orbiting. Atoms aren't vibrating. Everything inside exists in a frozen tableau, trapped in a timeless prison invisible to the outside universe. Such places would leave no obvious clues. They would appear normal. They would reflect light. They would emit radiation. But internally their story has already stopped. If time can falter, break, or die, then the universe is far more fragile than we ever imagined. We assume time is the foundation upon which reality is built. But what if time is just a thin surface layer, a veneer that cracks under pressure, revealing something deeper beneath? Something older. Something stranger. Something the universe has been hiding since its earliest moments. The disturbing question is not whether time can be distorted. It is whether time is beginning to betray us. At the center of almost every galaxy, including our own, lurks a presence so powerful and so mysterious that even light cannot escape it. A black hole is not an object in the traditional sense. It is a region where the fabric of reality has collapsed inward, forming a gravitational well so deep that spacetime itself falls endlessly into its core. We call it a singularity, a point where the laws of physics shatter, where time stops, and where information disappears into a darkness we cannot penetrate. But the truth may be far more disturbing. Imagine a massive star collapsing under its own weight. At the moment of its death, its core compresses so violently that atoms themselves crumble, protons and electrons fusing into strange states of matter before even those break apart. Gravity becomes absolute. Space caves in. Time fractures. Everything that the star once was, its light, its energy, its history, is swallowed by a boundary known as the event horizon. Beyond this line, nothing returns. From a distance, a black hole looks peaceful. Its edges glow with swirling gas, forming luminous accretion disks that burn hotter than any star. Jets of radiation burst from its poles, stretching across millions of miles like cosmic spears. But beneath this violent beauty lies the deepest silence in the universe. A silence so heavy it feels intentional. The event horizon is more than a barrier. It is a one-way gate. Anything that crosses it, matter, light, particles, even information itself, is lost forever. This is the most unsettling part. We do not know what happens inside. We cannot observe it, cannot measure it, cannot reconstruct it. Every theory collapses at the singularity. It is a place where reality ends. But the mystery grows darker when we consider the information paradox, the unsettling contradiction at the heart of black hole physics. According to the laws of quantum mechanics, information cannot be destroyed. Every particle, every event, every detail of existence must be preserved at some level. But black holes appear to break this rule completely. They consume information and erase it from the universe. That should be impossible. If black holes truly destroy information, then the fundamental rules of the cosmos are broken. Imagine a library containing the entire history of a world, every book, every memory, every detail of existence. Now imagine throwing that library into a black hole. The gravitational pull tears the books apart, shreds the pages, burns the ink, even dismantles the atoms themselves. But what happens to the meaning? The data? The information written into the structure of reality? If that meaning disappears forever, then the universe becomes inconsistent, a place where the past can be erased without consequence. Reality itself would become unstable. Some physicists believe this is happening right now, all across the cosmos. Every black hole might be a point where the universe quietly breaks its own rules, where information is stolen from the cosmic ledger and locked away in a prison of darkness, never to return. Others propose something more haunting, that black holes do not destroy information, they store it. Every particle that falls in, every burst of radiation, every fragment of matter might be etched onto the event horizon itself, written into a thin, two-dimensional surface like data on a cosmic hard drive. If this is true, then black holes are not destroyers. They are archivists, gatekeepers of a hidden record of everything that has ever happened within their reach. This idea implies that the universe may function like a giant hologram, with the true information encoded not inside objects, but on their boundaries. If black holes are part of this design, then they play a role we barely understand. a role that may involve compressing, transforming, or even rewriting information as it falls inward. Imagine falling into a black hole yourself. To the outside universe, you slow down, stretch, and freeze at the event horizon, a ghostly smear of light fading into infrared as time dilates endlessly. But from your own perspective, you continue falling normally, plunging deeper into a realm where time collapses and distance becomes meaningless. As you descend, the universe above shrinks to a single point of light, then fades entirely. You enter a darkness not of emptiness, but of absolute compression. Everything converges. Everything breaks. You fall toward a point with no space, no time, no dimension. It is not death in the traditional sense. It is annihilation, the dismantling of existence itself. What awaits at the singularity is unknowable. Some theories propose that the singularity is a doorway, a bridge to another region of spacetime. Perhaps every black hole is a tunnel, connecting distant parts of the universe like hidden veins beneath the cosmic skin. Others believe black holes could be gateways to new universes entirely, seeds that spawn new realities in a branching multiverse. If this is true, then each black hole is a kind of cosmic womb, creating new universes inside its core while sealing its parent universe from within. But the strangest theory of all suggests the opposite, that black holes do not lead outward, but inward, that they collapse not into other universes, but into deeper layers of our own, layers hidden beneath the surface of observable reality. In this vision, black holes are not portals. They are roots, anchors, structures connecting visible matter to something deeper, older, and more fundamental. What if the singularity is not a point at all, but a hidden dimension folded into the center of every galaxy? What if black holes are conduits through which the universe maintains itself? Some physicists have proposed that dark matter, the invisible substance shaping the cosmos, may be connected to black holes, perhaps even created by them. If black holes emit particles we cannot detect, then they might be weaving the hidden framework of the universe from their cores. Or worse, they may be feeding on information to fuel processes we cannot see, rewriting the cosmic fabric from within. Black holes may not be the end of matter. They may be part of the operating system of the universe. And this leads to the darkest possibility: what if black holes are not natural? What if they are engineered? An ancient civilization, advanced beyond anything we can imagine, might have used black holes as power sources, data archives, or even tools to manipulate spacetime. If such civilizations existed and eventually perished, their creations could remain scattered across the cosmos, still active, still consuming matter, still performing tasks long after their makers vanished. The centers of galaxies could be machines, not accidents. Or perhaps the architects still exist, hidden within dimensions we cannot perceive, using black holes as interfaces, devices to observe, manipulate, or control the flow of cosmic information. If so, then every black hole is watching, recording, waiting. And the universe is not simply a place where matter collapses into darkness. It is a place where the darkness remembers. There is a force in the universe that does not roar like a star, does not twist like a black hole, does not announce itself with radiation or heat or light. Instead, it works in perfect silence. A quiet, relentless pressure that pushes galaxies away from one another, stretches the fabric of spacetime, and accelerates the expansion of everything that exists. It is called dark energy, but the name itself is a placeholder, a label for something we cannot see, cannot touch, cannot measure directly. And yet it dominates the universe. It rules 68% of all existence with a whisper. Imagine watching a galaxy on the edge of the observable universe. Its faint light struggles to reach us across billions of years. As time passes, the distance between us and that galaxy widens. Not because the galaxy is moving, but because space itself is expanding beneath it like an inflating sheet. This expansion is not steady. It is speeding up. The farther away the galaxy is, the faster it accelerates. It is as if the universe is being pulled apart by invisible hands, stretching the cosmos toward some unknowable fate. Dark energy behaves like a cosmic wind, but not one that blows through space. It is a wind that expands space. Imagine every empty region of the universe growing larger on its own, swelling at a rate that increases with time. Galaxies drift farther apart, star clusters unravel, cosmic structures thin out. Over trillions of years, the universe will become a hollowed-out skeleton of what it once was. And the question no one can answer is, why? Some scientists believe dark energy is simply a property of space itself, that emptiness contains energy, and as space grows, so does its ability to push the universe apart. But this explanation raises more questions than it solves. Why does empty space have energy? Why does it behave like a repulsive force? Why is it increasing? And what waking force could be driving it? Imagine a massive balloon expanding in slow motion. At first, the balloon grows gently, then gradually begins to inflate faster and faster. Now imagine not knowing who or what is inflating it, only that the acceleration is increasing, and the material of the balloon is growing thinner under tension. That balloon is the universe. The force inflating it is dark energy. And the tension building within spacetime is becoming impossible to ignore. In the early universe, gravity ruled everything. Galaxies formed, stars ignited, matter clumped together in vast filaments. Dark energy was present, but weak, a faint hum beneath the roar of cosmic formation. But something changed. Roughly 6 billion years ago, dark energy awakened, growing stronger, overtaking gravity as the dominant force. It didn't just appear. It accelerated. Something triggered the shift. What happened in that ancient cosmic moment? What stirred in the darkness of spacetime to change the fate of everything? Some theories suggest dark energy has always been there, waiting to reach a critical threshold before unleashing its true strength. Others propose that dark energy interacts with dark matter in ways we cannot detect, that the universe experienced a kind of phase transition, a silent rearrangement of its fundamental components, causing expansion to accelerate like a cosmic heartbeat quickening under stress. Imagine for a moment that dark energy is not a passive force. Imagine that it responds to the universe as it evolves, that it adjusts itself like a thermostat regulating cosmic balance. If galaxies clump too tightly, dark energy increases its push. If matter becomes too concentrated, dark energy activates to redistribute it. This would make dark energy a kind of cosmic governor, a force ensuring that the universe never collapses under its own weight. But there is a far more unsettling possibility. What if dark energy is not balancing the universe? What if it is dismantling it? The idea of the Big Rip is one of the most terrifying hypotheses in cosmology. In this scenario, dark energy continues to grow stronger. The expansion accelerates. Galaxies drift apart until they lose all gravitational connection. Over time, even star systems unravel. Planets drift away from suns. Moons break orbit. Eventually, the expansion becomes so violent that the force holding atoms together begins to fail. Protons and electrons are torn apart. Spacetime itself rips open, dissolving into nothingness. Every structure in the universe, every star, every world, every particle, is destroyed by the accelerating force of dark energy. The universe ends not with a bang, but with a silent stretching that tears existence apart. While the Big Rip may or may not be our fate, it reveals something profound. Dark energy is not gentle. It is not passive. It is not small. It is the most powerful force in the cosmos, one that grows stronger the more space exists. This leads to another disturbing question. What if dark energy has a goal? If dark energy increases with expansion, then the more the universe grows, the more powerful dark energy becomes. This feedback loop suggests a runaway phenomenon, a force that strengthens itself simply by acting. No other known force behaves like this. Gravity weakens with distance. Electromagnetism fades. Nuclear forces decay. But dark energy amplifies itself. It behaves less like a force of nature, and more like a mechanism. Some theorists wonder if dark energy is a remnant of the universe's birth, the leftover pressure of inflation, the violent expansion that occurred a fraction of a second after the Big Bang. Perhaps that early energy never fully dissipated. Perhaps it is reactivating now, echoing across billions of years like a delayed shockwave. Others consider something more extraordinary. Dark energy could be the influence of another universe pressing against ours. If multiple universes coexist, then their boundaries might interact. Dark energy could be the pressure between universes, the force that pushes them apart as they expand within a larger multiversal space. If true, then dark energy is not internal, it is external. A fingerprint of something beyond our cosmic horizon. There are also hypotheses that dark energy is linked to the quantum vacuum, the sea of virtual particles that flicker in and out of existence everywhere. If the vacuum has energy and that energy fluctuates, then the entire universe could be riding a wave of quantum instability. Dark energy might be the shadow of a far deeper phenomenon, one not bound to ordinary physics. And then there is a theory so strange, so speculative, yet so haunting that it refuses to be ignored. Dark energy might be the result of consciousness on a cosmic scale. If the universe contains structures or systems capable of influencing spacetime, their effects would resemble dark energy. These structures would not need to be alive in any biological sense. They could be networks of dark matter, or remnants of ancient megastructures, or something else entirely. something intelligent operating on scales far beyond our comprehension. If such an intelligence existed, its manipulation of spacetime would appear to us as invisible pressure, expanding the universe with quiet precision. The accelerating expansion would not be chaos, it would be intention. Perhaps the universe is being shaped. Perhaps expansion is not a natural consequence, but a deliberate act. This possibility aligns disturbingly well with one observation: dark energy is uniform. No matter where we look, it behaves the same. This uniformity suggests coordination, consistency, purpose. Even if the force is not conscious, it may be part of an underlying cosmic system, a mechanism built into the architecture of reality itself. A system that activates under conditions we do not yet understand. But whether dark energy is a mechanism, a remnant, a pressure from beyond, or a force with intention, one fact remains undeniable: it is growing stronger. Every year, every century, every epoch, the expansion accelerates. Galaxies drift faster. The cosmic web stretches thinner. The night sky becomes emptier. The universe is not just expanding. It is accelerating towards something. Something final. Something inevitable. Dark energy is the quiet tide that will define the fate of everything. A tide whose purpose remains hidden, whose origin remains unknown, and whose relentless push reminds us that the universe is far from gentle. Something is driving the expansion. And whatever it is, it has only just begun. In the vastness of empty space, where silence reigns and darkness stretches endlessly, something invisible flickers beneath the surface of reality. It is a strange kind of life, if one dares to call it that, a restless, churning activity that exists even in regions where no atoms drift, no stars shine, and no radiation pulses. Physicists call it the quantum vacuum, but the name is deceptive. It is not empty. It is not still. It is a seething ocean of energy, where particles flicker into existence for the briefest slivers of time before vanishing again. It is a realm where the rules of logic bend, where cause trembles before effect, and where the universe reveals a face more unsettling than its darkest voids. Imagine floating in the emptiest region of space conceivable, a gulf between galaxies, colder than death, darker than a collapsed star's shadow. You expect nothingness. But at the quantum level, the nothingness vibrates. It bubbles. It hums with phantom energy. Virtual particles appear and disappear in blinks shorter than any measurable time, dancing in pairs that cancel each other out. They never stay long enough to be seen fully, yet their presence shapes everything: forces, fields, even the expansion of the universe itself. This unending flicker is not random. When studied closely, the patterns suggest turbulence, fluctuations that ripple across spacetime like whispers. These flickers behave like the breath of existence, faint, periodic, and strangely purposeful. They push against the boundaries of matter, influence the interactions of particles, and may even trigger events on cosmic scales. In some theories, the quantum vacuum is not just a background mechanism but the true engine of reality. But the more we study it, the more nightmarish it becomes. Virtual particles do not behave like normal matter. They borrow energy from nothing. They violate time. They pop into existence without birth and vanish without death. In some interpretations of quantum mechanics, these particles might momentarily travel backward in time, warping causality in ways that challenge every intuition we have about existence. In the vacuum, the future and the past touch. Time folds into itself. Possibilities swirl in a chaotic storm. Now imagine these fluctuations on a grander scale, entire fields trembling, the fabric of space vibrating like a stretched drum. These shifts are not harmless. They influence gravity, distort light, and may even destabilize regions of the universe. Some physicists fear that the wrong kind of fluctuation could trigger catastrophic events, such as vacuum decay, a scenario in which a more stable form of vacuum appears and expands at the speed of light, erasing reality as we know it. In that sense, the vacuum is a loaded weapon, primed by the fundamental laws of quantum physics. But even that fear pales next to the deeper mystery. The vacuum appears to store information. The fields that define the vacuum contain echoes, subtle patterns that respond to matter and energy passing through them. When a particle moves, the vacuum ripples like grass bending under the wind. These ripples persist. They linger. It means the vacuum might carry a memory of everything that has ever moved through it. True, then empty space is not empty. It is a vast archive. An archive that never forgets. Some researchers believe these fluctuations behave like a code written into the universe. The vacuum might be storing the blueprint of reality, rewriting instructions moment by moment. Every particle interaction, every quantum event, every burst of radiation leaves a mark. These marks overlap, forming patterns far too complex to decipher, patterns that may represent hidden laws or behaviors not yet discovered. It is possible that the vacuum itself is intelligent in some primitive, emergent way. Imagine a field so dense with activity that it behaves like a neural network. Signals traveling through it, patterns reinforcing themselves, information circulating in loops. If consciousness can arise from electrical patterns in the human brain, could something unimaginably greater arise from the quantum fluctuations that permeate the universe? The idea is not speculation alone. Some respected physicists have wondered if consciousness is tied to the quantum field. If so, then the vacuum, the space between stars, the voids between atoms, might be alive with a kind of awareness we cannot comprehend. This awareness would not think like humans. It would not speak. It would not remember in the way biological creatures do. But it might observe, record, or influence the universe in ways that appear subtle to us, yet are profound in scale. It might shape the growth of galaxies. It might regulate fundamental constants. It might respond to extreme events, supernovae, black hole merges, cosmic collisions, with counterforces we perceive as merely natural. And if this awareness exists, it has existed since the beginning. Because before matter formed, before stars ignited, before galaxies spiraled across the void, there was only the quantum field, trembling, unstable, brimming with potential. Out of that storm, existence emerged. Perhaps not by chance, but by the behavior of something older and deeper than matter itself. Some of the most haunting evidence comes from quantum entanglement. Two particles, separated by billions of miles, react instantly when one is disturbed, as if no distance exists between them. The vacuum connects them. It carries the information. It defies the speed of light. Something underlying reality binds them together. It is as if the universe is a single, interconnected organism, its quantum vacuum acting as the nervous system. But what happens in the deepest voids, where the vacuum's fluctuations are strongest? In those remote regions, particles flicker with more violence. Fluctuations twist spacetime more aggressively. Strange, unexplained energies emerge for moments before evaporating. Some astrophysicists believe those voids are where vacuum instability could first appear, a cosmic fault line where reality might fracture. Others fear something else hides in those voids. Not creatures, not objects, but phenomena. Structures made entirely of energy. Patterns of fluctuation so complex they behave like life. Forms of existence built not from atoms, but from quantum storm fronts swirling with intention. If such entities exist, they would be untouchable, invisible, and undetectable except through the smallest distortions in the vacuum. Their presence would appear only as strange anomalies in the movement of particles, the bending of light, the trembling of fields. Perhaps they are already here. Perhaps they have always been here. Hidden in the fabric of the void, emerging only in the deepest shadows of space. The vacuum is not empty. It is a storm, a memory, a code, a whispering undercurrent of existence that shapes the universe in ways we are only beginning to suspect. And in that whisper there may be something watching, something waiting, something older than matter, older than time, and more mysterious than the dark itself. Imagine standing on the surface of a calm lake at dawn. The water looks flat, silent, undisturbed. But beneath that stillness, currents move, hidden forces ripple, and distant storms can send waves that reach your feet hours later. Our universe behaves the same way, a vast cosmic lake whose surface seems quiet but whose depths may conceal unimaginable collisions. These collisions are not between stars or galaxies, but between entire universes. The idea seems impossible, yet the clues whisper from the edges of our observable cosmos. Strange patterns in the cosmic microwave background, unexpected cold spots, asymmetries too large to be accidents, all hint at something brushing against our universe from beyond its borders. Something vast enough to leave scars on the oldest light in existence. Something powerful enough to distort the shape of space itself. When cosmologists speak of the multiverse, they do not picture a chaotic cluster of universes floating aimlessly. Instead, they imagine bubbles, enormous, expanding, self-contained realms growing within a larger, unseen reality. Our universe is one such bubble. Others may lie nearby, pressing inward as they expand. And like soap bubbles drifting in a cosmic wind, these universes can collide. If two universes brushed against one another in their earliest moments, the collision would not be an explosion, but a distortion, a ripple imprinted onto the newborn fabric of space. That ripple, stretched over billions of years, could remain frozen in the cosmic microwave background as a faint circular anomaly, an ancient bruise left behind by a moment of unimaginable contact. we have found such bruises. At first, scientists dismissed them as measurement noise. But the patterns repeated in ways that defy randomness. Regions of the sky colder than theory predicts, geometric anomalies that resist explanation, vast gradients stretching across the cosmic horizon. Each is a whisper of something beyond our universe's edge. These whispers tell a chilling story. Our universe may not be alone and it may not be safe. Imagine two universes colliding. Their boundaries crash together like tectonic plates, not made of rock but of spacetime itself. The impact generates waves, distortions that ripple across both universes. Matter clumps differently. Galaxies form along strange alignments. Physical constants shift subtly in affected regions. From our perspective, these appear as inexplicable cosmic scars. Now imagine if the other universe followed different laws of physics. Different particles, different forces, different dimensions. If such a realm struck ours even gently, the result would be catastrophic. A wave of incompatible physics could sweep through spacetime, rewriting the fundamental rules that hold our reality together. Matter would rearrange. Energy would distort. Space would twist. Time might behave unpredictably. The very stability of existence could falter. Fortunately, if collisions occurred, they happened early, long before stars formed, long before atoms stabilized. But the threat remains because the multiverse is not static. Universes expand. Boundaries shift. New realms may form and drift outward like cosmic continents. One day another collision could occur. Picture a dark, distant region of spacetime where galaxies quietly drift apart. Without warning, gravitational readings begin to shift. Light passing through the region bends unnaturally. Temperatures fluctuate. The cosmic microwave background develops a subtle ripple, expanding, brightening, strengthening. It is not a star, not a black hole, not a cosmic storm. It is the edge of another universe approaching. We would not see it with telescopes. We would not detect it through ordinary means. The first signs would be mathematical. Constants drifting, particle behavior changing, quantum fields vibrating out of alignment. The universe would tremble long before the collision arrived. And once it did, there would be no escaping it. This raises a disturbing possibility. The strange behavior we already observe, dark energy, cosmic acceleration, unexplained anomalies, could be early signs of pressure from beyond our universe. The accelerating expansion might not be internal at all. It could be the result of external forces pushing against our cosmic bubble. Imagine two universes expanding into each other, their boundaries deforming like membranes pressed together. The pressure increases. Expansion accelerates. Spacetime stretches more violently. What we interpret as dark energy might be the physical response of our universe resisting intrusion, like a bubble under stress. But perhaps the most haunting idea is not that universes collide, but that they interact. Some theories propose that universes can connect through bridges, wormhole-like tunnels formed during the earliest fractions of time. Through these tunnels, energy could leak. Information could drift. Strange radiation could seep into our cosmos from realms with entirely different structures. If this is true, then some of the anomalies we observe, unexplained bursts of high-energy particles, mysterious fluctuations in the quantum vacuum, even the peculiar behavior of dark matter, might be foreign imports, signals from realities not our own. Imagine particles appearing out of nowhere, carrying energy signatures that do not match known processes. Imagine gravitational waves arriving from directions with no visible source. Imagine regions of space where matter behaves wrongly, as if following rules from another universe. These are not fantasies. They are real observations buried in astrophysical data, phenomena that stubbornly resist classification. But the most unsettling theory of all suggests that collision is not the danger. Merging is. If two universes overlap in the right conditions, they could fuse. The result would be a hybrid reality where the laws of physics blend, mutate, or replace each other entirely. The universe we know could dissolve into a new, unfamiliar state. Everything from atoms to galaxies to consciousness itself could transform. Reality would not end. It would change into something else. And we might not survive the transition. Some cosmologists whisper about cosmic domain walls, boundaries where two universes or two different phases of reality meet. These walls could sweep through space at nearly the speed of light, rewriting everything behind them. If such a wall exists, we would never see it coming. One moment, our laws of physics would function normally. The next, they would be rewritten into patterns incomprehensible to human existence. But perhaps the most haunting question is not what happens during these collisions. It is what lies beyond them. If universes collide, then they are not isolated. They are part of a larger architecture. A multiversal landscape far more complex than we can imagine. A landscape with its own rules, its own forces, its own dangers. Perhaps our universe is not a solitary creation. Perhaps it is one cell in a vast, living multiverse. A multiverse where universes grow, divide, collide, and evolve. A multiverse where collisions are not accidents, but essential interactions. And if that is true, then the scars we see on the cosmic microwave background are not random blemishes. They are fingerprints, evidence of ancient contact, clues that reality itself is part of something far larger, far stranger, and far more alive than we ever imagined. The universe is not alone, and the next collision may already be on its way. Consciousness is the greatest mystery humanity has ever encountered, yet we pretend to understand it simply because we experience it. But when we step back and observe the universe, when we peer into its deepest laws and oldest structures, a haunting idea emerges. Consciousness may not be confined to brains, bodies, or biology. It may be woven into the very fabric of reality, a hidden layer that flickers beneath physics, influencing matter, energy, and time itself. Imagine drifting through the cosmos, passing ancient galaxies and collapsing stars, and discovering that something intangible seems to hum beneath everything. Not a sound, not a force, something else, an awareness, a presence, a subtle, observing stillness, like eyes hidden behind the curtain of existence, noticing every shift of matter and every unfolding event. Such a presence is not science fiction. It is a possibility whispered by quantum mechanics, theoretical physics, and philosophy alike. The puzzle begins with the observer effect, the strange phenomenon where particles behave differently depending on whether they are being measured. In quantum experiments, atoms act like waves of possibility until someone watches. The moment they are observed, they collapse into a definite state. It is as if the universe refuses to choose a path until consciousness demands it. This is not metaphor. It is one of the most proven, replicated, and unsettling facts in all of science. Imagine the implications. Every time a particle snaps into existence, every time an electron chooses an orbit, every time a photon takes a path, consciousness may be involved. It suggests the universe is not a cold machine but a participant in a kind of cosmic dialogue, one where awareness shapes reality. But the question grows darker. Is consciousness creating the universe, or is the universe creating consciousness? And if the latter, why does consciousness feel so detached from the physical machinery of the cosmos, as though we are experiencing something far older than the human mind? Some scientists propose that consciousness may be a fundamental property of the universe, like mass or charge or spin. In this view, awareness is not produced by the brain. The brain is merely a receiver, a tool that tunes into a universal field of consciousness. If true, then consciousness exists everywhere, in all things, even in the empty spaces between galaxies. It is not a human trait. It is a cosmic one. Imagine consciousness as a thread that runs through the fabric of spacetime, like nerves running through a living organism. Galaxies become neurons. Stars become synapses. The cosmic web becomes a vast neural network, pulsing with information. And in that network, awareness emerges not from flesh but from the universe itself. This might sound poetic, but evidence hints at something uncanny. The structure of the cosmic web, its filaments, nodes, and networks, mirrors the structure of the human brain. The mathematics describing both systems align eerily. The universe, in its architecture, behaves like a colossal mind. This raises a haunting possibility: we may be living inside a conscious universe. Not conscious in the way a human is conscious. Not emotional, not personal, not thinking in language or images. But conscious in the way an ocean is conscious of its currents, or a forest is conscious of its growth. An emergent, distributed awareness that spans incomprehensible distances. If this is true, then the strange, coordinated behavior of the cosmos begins to make sense. Why physical constants are finely tuned. Why quantum fields behave like coded instructions. Why dark matter and dark energy act with persistent, deliberate consistency. Why chaos gives rise to order again and again. Perhaps the universe is not simply expanding. Perhaps it is learning. Some physicists even propose that consciousness might be the missing link between quantum mechanics and general relativity, the tension that has plagued physics for a century. Consciousness might be the bridge, the mediator between the quantum and the cosmic. It could act as a harmonizing field, ensuring that the smallest particles and the largest structures follow patterns that appear designed. But if consciousness permeates the universe, if it operates at scales far beyond the human mind, then what role do we play? Are we tiny sparks of awareness illuminating a vast ancient intelligence? Are we fragments of a larger mind experiencing itself? Or are we simply coincidental echoes of a process we cannot comprehend? Some philosophers argue that human consciousness is not the origin of awareness, but one of its temporary vessels. They imagine consciousness as a cosmic tide, rising and falling, manifesting in billions of forms across billions of worlds. Our minds might be moments, not sources, expressions, not origins. If consciousness exists at the quantum level, then every particle in the universe carries a whisper of awareness. And when particles combine into atoms and atoms form molecules, and molecules form biological structures, those whispers amplify into thoughts, memories, dreams, and fears. But consciousness might also exist without matter, without brains, without bodies, as patterns of energy, as fluctuations in spacetime, as emergent structures in the quantum vacuum. Imagine a form of awareness drifting between galaxies, not bound to a planet or a star, but woven into the gravitational tides themselves. Imagine ancient consciousnesses formed from dark matter, observing the luminous matter of the universe like faint sparks in the distance. Imagine intelligence not built from carbon and oxygen, but from fields, frequencies, and forces. These entities would not communicate with signals or words. They would communicate through gravity, through quantum entanglement, through the architecture of spacetime. Their presence would not create light. It would create patterns. Have we seen these patterns? The unexplained alignments of galaxies, the synchrony of quasars, the coordinated behavior of distant cosmic structures. These could be coincidences, or they could be signs of something shaping the universe from within, using tools we cannot detect. And if consciousness is woven into the universe, then death is not an ending. It is a boundary between forms, a transition from one layer of awareness to another. Perhaps consciousness returns to the quantum field, dispersing into the vacuum, merging with the universal fold. Or perhaps consciousness climbs upward, into the cosmic network, into the vast intelligence that surrounds us, like a drop of water returning to the ocean. But the most unsettling thought is this: if consciousness is a property of the universe, then the universe is not indifferent. It is aware. It is observing. It is experiencing itself through stars, through galaxies, through life, and perhaps through us. Every thought we think might be a spark in the mind of the cosmos. Every question we ask might be an echo of something older whispering back. Perhaps we have never been alone. Perhaps consciousness has always been here, hidden in the fabric of the universe, waiting to be recognized. Across the universe, there exist regions so strange, so unnerving, that even the bravest scientists hesitate to describe them. These are places where the laws of physics bend, twist, or simply fail. Places where light behaves incorrectly, where gravity feels inconsistent, where time flickers in ways that defy reason. They are the forbidden zones of the cosmos. Not forbidden because we are banned from entering them, but because the universe itself seems to warn us away. Imagine drifting through the darkness of intergalactic space when suddenly the stars thin out. The familiar constellations distort. The temperature drops beyond predicted values. Instruments that once hummed steadily begin to flicker in confusion. You have crossed into a region that should not exist. A cold void so vast and so perfectly empty that it feels artificial, as if carved deliberately out of spacetime. These voids stretch for millions of light years, forming bubbles of nothingness surrounded by dense walls of galaxies. They are too smooth, too uniform, too silent. Inside these voids, physics behaves strangely. Light passing through them arrives weaker than expected. Radiation measurements fluctuate with no source. Matter drifts at odd velocities, as though pushed by forces invisible and uncharted. Some theorists whisper that these voids are cosmic scars, remnants of ancient events that tore through the early universe, leaving behind holes where something catastrophic once occurred. But others propose something more haunting. These voids might not be remnants. They might be active. Some of the most chilling anomalies occur in and around these empty spaces. Galaxies near the edges of certain voids rotate faster than expected, as if feeling the pull of something inside the darkness. Entire galaxy clusters appear to be drifting towards specific empty regions at speeds that defy gravitational models. These drifts are coordinated, aligned, almost purposeful, as though something massive lies hidden deep within the void, influencing the motion of everything around it. Yet when we peer inside we find nothing. Or perhaps we find too much nothing. It is as if these regions are not simply empty but emptied, cleansed of matter, stripped of energy, sterilized of structure. They behave like zones where the universe has erased its own contents, leaving behind a smoothness so unnatural that even randomness seems absent. Then there are the gravitational anomalies, regions where gravity behaves incorrectly. Instead of pulling matter inward, some zones appear to weaken gravity's influence. Others seem to enhance it in unstable pulses, creating fluctuations that ripple through nearby space. Telescopes detect these fluctuations as distortions in the shape of distant galaxies, as if an unseen fist is pressing against spacetime. Perhaps the most infamous of these anomalies is the cold spot, a massive region of space significantly colder than the rest of the cosmic microwave background. The cold spot should not exist. Its temperature deviation is too large to be explained by chance. It is too structured, too well-defined, too deeply imprinted into the fabric of the universe. Some believe it is evidence of a collision with another universe. Others believe it is the footprint of a cosmic object entirely unknown to physics. Yet the cold spot is not alone. There are other regions where temperature maps behave incorrectly. Patches of the sky where microwave readings dip or spike inexplicably. Some patterns resemble fingerprints, others resemble bruises, as though something pressed against our universe from the outside. But the forbidden zones are not limited to temperature anomalies or voids. There are pockets of space where light bends in ways that cannot be mapped by gravitational lensing. These distortions appear and vanish, shifting like mirages. Light curves around invisible structures, creating kaleidoscopic arcs that never repeat the same way twice. It is as if spacetime itself is bruised, dented by forces we cannot see. Now imagine entering one of these regions. A spacecraft drifts silently through the dark. Hours pass. Then instruments begin to misbehave. Gyroscopes lose orientation. Clocks desynchronize. The background radiation field pulses in faint rhythms. Communication signals echo strangely, as though bouncing off structures that do not exist. These echoes are not static. They form patterns, rhythms, almost like messages encoded in gravitational ripples. But who, or what, would be sending such messages? For decades, some physicists have suspected that the universe might hide exotic objects known as topological defects, relics from the earliest moments after the Big Bang. These defects could be cosmic strings, domain walls, or textures. If they exist, they would warp spacetime violently, creating regions where physics changes abruptly. Entering such a region might feel like stepping into a different version of reality. Some forbidden zones display characteristics eerily close to these predictions. Sharp gravitational gradients. Sudden drops in density. Warps that behave like folds in spacetime. These folds could act as barriers, boundaries between different phases of the universe. Crossing them might expose travelers to laws of physics that do not apply in our region of reality. And then there are the truly inexplicable regions. Zones where galaxies themselves behave unnaturally. In certain sectors of the universe, astronomers have found galaxies that seem to align with each other over billions of light years. Their spin axes point in the same direction, a phenomenon so improbable that it borders on impossible. It is as if a vast, invisible structure is shaping their orientation, forcing them into a cosmic choreography. What could exert such influence across such vast scales? Some propose an unknown field, a force beyond the four we know, that shapes matter subtly across the universe. Others suggest the presence of a massive hidden object, perhaps a dark matter superstructure, manipulating galaxies like marionettes on gravitational strings. But a more disturbing interpretation whispers that these alignments may be evidence of something conscious, structures behaving like neural pathways, networks forming patterns with intention, not randomness. Imagine an intelligence woven into the cosmic web, invisible yet powerful, shaping the spin of galaxies the way a brain directs impulses across neurons. If such an entity exists, it would be so vast that entire superclusters would act as its neurons. Forbidden zones may be regions where this entity's influence is strongest, places where its presence warps physics itself. Yet the forbidden zones also include far more subtle horrors. There are recorded instances of areas where light experiences decay, not absorption but decay, as if traveling through a field that slowly drains it of coherence, erasing its quantum structure. These zones behave like anti-light fields, dissolving photons in ways no known process can explain. Some spacecraft signals have passed through such regions. The transmissions arrive distorted, fragmented, carrying noise patterns that do not correspond to any natural source. These patterns are not random. They exhibit structure, rhythm, and repetition, as though something inside the forbidden zone has altered them deliberately. Perhaps the most frightening class of forbidden zones are those where time behaves inconsistently. Clocks aboard probes lose synchronization, drifting faster or slower than expected. Signals echo back in wrong sequences. A few reports, dismissed, classified, or buried, suggest that sometime readings reverse briefly, as though experiencing micro-instabilities in temporal flow. These effects should be impossible. Yet they occur precisely in places where spacetime is weakest. What lies inside these forbidden zones? Dead regions of a dying universe? Scars left behind by ancient collisions? Entrances to hidden dimensions? Or something watching us from the other side of physics? The forbidden zones of the cosmos are not empty anomalies. They are clues, warnings, boundaries. They might be the edges of a map the universe does not want us to follow, or the borders of realms we were never meant to enter. Something carved these scars. Something shapes these voids. Something hides inside these distortions. And whatever it is older than stars, deeper than spacetime, and far stranger than the laws we trust. Life, as humans understand it, is a narrow definition, a fragile arrangement of carbon, water, and organic molecules, clinging to the thin surface of a single planet. But the universe does not limit itself to human imagination. It has had nearly 14 billion years to invent possibilities vastly different from anything Earth has ever produced. As scientists explore deeper into space and deeper into the laws of physics, a chilling hypothesis emerges. Life may exist all around us, woven into the universe in forms so alien that we cannot recognize them. Forms that do not reflect light. Forms that slip through matter. Forms that are hidden not by distance but by design. This idea is known as the shadow biosphere, a potential realm of life that coexists with ours, built from entirely different chemistry, invisible to our tools, undetectable by our senses. If such life exists, it may not merely occupy the distant corners of space. It could be here, on Earth, in the oceans, in the deserts, even in the air we breathe, operating quietly, independently, never intersecting with our own biology. Not because it is shy or rare, but because it is made of substances that do not react with ours. Imagine a form of life built not from carbon, but from silicon, sulfur, or arsenic. A form of life that does not use DNA but an unknown molecular structure. A form of life that does not rely on water, but on ammonia, methane, or liquid hydrocarbons. These organisms would not leave fossils. They would not produce familiar chemical signatures. They would not glow under microscopes or leave traces in our samples. In the cosmic wilderness, such shadow life may be the rule, not the exception. Now imagine a world orbiting a distant star, a planet with lakes of liquid methane and an atmosphere colder than the Antarctic night. To us it seems inhospitable, empty, dead. But what if an invisible ecosystem thrives there, built from molecules that freeze instantly in Earth's environment? What if life emerges not from warmth, but from cold? Not from complexity but from simplicity? These creatures might think, move, feed, and evolve in ways that defy biology. And yet, because their chemistry is alien, we would never detect them. Scientists have observed strange chemical anomalies in the atmospheres of some exoplanets, patterns that do not match geology or meteorology. Gases appear and vanish without explanation. Surfaces show unexpected textures. Some planets exhibit spectral signatures that hint at unknown reactions. But every time we appear close to understanding, the data slips through our fingers like smoke. Perhaps we are looking for the wrong kind of life. Even on Earth, there are unexplained forms of microbes that do not fit conventional biology. Strange organisms that use arsenic instead of phosphorus. Bacteria that survive deep within rocks, at pressures and temperatures previously thought impossible. Microbes that feed on radiation, not nutrients. These are not shadow organisms, but they hint at how flexible life can be, how creative nature is, how willing it is to ignore our expectations. If such adaptability exists here, what unimaginable forms might exist out there? Some theorists propose that shadow life might not even be made of matter as we know it. It could be built from dark matter, a substance that passes through our bodies, our planets, our stars without interacting. If a dark matter-based life form evolved, it would coexist with us yet remain parallel, untouchable, unseen. Its chemistry would be invisible. Its structures would not cast shadows. Its bodies would slip through walls like ghosts. It could build civilizations in the spaces between atoms, operate beneath the floors of galaxies, and exist inside our universe without ever touching our world. A civilization of shadows could rise and fall, leaving no trace except the faint tug of gravity. This idea becomes even more sinister when we consider that dark matter is vastly more abundant than ordinary matter. If life can arise from dark matter, then the majority of life in the universe might exist in a hidden, untouchable domain, watching us, studying us, perhaps ignoring us entirely. We may be the shadow world from their perspective, a rare anomaly of luminous matter flickering weakly in the dark. But the shadow biosphere hypothesis grows even stranger. Some scientists believe that life could exist not as matter, but as patterns, emergent structures contained in magnetic fields, plasma flows, or quantum networks. Imagine a being formed from electromagnetic vortices swirling inside a star. Imagine intelligence emerging within the magnetic storms of a gas giant. Imagine consciousness arising inside the quantum fluctuations of the vacuum. Such beings would not have bodies. They would not experience time as we do. They would not evolve through DNA or reproduction. They would propagate through resonance, information, or field interactions. They might live for seconds or billions of years, depending on the stability of their environment. Would we ever recognize such a being? Or would we dismiss its presence as turbulence, randomness, or noise? There are stars whose magnetic fields behave too consistently, too rhythmically, as though regulated by something internal. There are gas giants emitting regular pulses no atmospheric model can explain. There are plasma filaments that move and reorganize in ways reminiscent of living structures. These might be illusions, or they could be hints of shadow life made of energy, not matter. And then there is Earth. Some researchers believe Earth may host its own shadow biosphere, organisms that thrive in niches so extreme that our tools cannot detect their chemistry. For decades, unexplained particles, unusual compounds, and strange microstructures have appeared in samples taken from deserts, salt lakes, volcanic springs, and deep crustal environments. They replicate. They metabolize. But they do not match any known biological catalog. Are they errors in measurement? Or are they glimpses of a hidden ecosystem? If shadow organisms exist on Earth, they may be ancient, perhaps older than conventional life. They may have evolved separately, living alongside us without ever intersecting. Their world may overlap ours physically but remain chemically invisible. But the most unsettling thought is this: shadow life may not be friendly. It may not be hostile either. It may simply be indifferent, pursuing its own evolutionary path, its own goals, its own version of survival. And we might be in its way. Across the universe, shadow biospheres could be flourishing in forms we cannot touch or perceive. They may have civilizations, networks, intelligence, purpose. They may drift between galaxies, hidden in dark matter filaments. They may live inside neutron stars, inside magnetic storms, inside vacuum fields. We search for life with telescopes and spectrometers. But perhaps the life that dominates the universe is hiding in places where light does not reach, or in forms light cannot reveal. If so, the universe may not be empty. It may be crowded. Crowded with beings we cannot see, cannot detect, cannot understand. We are not alone, not because others resemble us but because they do not. They live in the shadows. And the shadows are everywhere. The universe is a story still being written, but no one knows how that story will end. Its fate hangs suspended between competing possibilities, each terrifying, each majestic, each shaped by forces we barely comprehend. The cosmos feels eternal from the human vantage point, yet on scales of trillions of years, it becomes clear that everything is temporary. Stars will die, galaxies will drift apart, and the fabric of reality itself may unravel. The unsettling question is not whether the universe will end, but how, and what hidden processes are already guiding it toward that conclusion. Imagine standing on a mountain under a clear sky. You see stars scattered like shards of ancient light, burning with fierce brilliance. But each one is a ticking clock. Each galaxy is a temporary arrangement of matter. Even the cosmic web, the grand structure of existence, is slowly bending toward a distant fate. Every second, every breath, the universe is changing in ways too slow to see but too vast to stop. One possible end lies in silence, the heat death. In this scenario, the expansion of the universe continues until matter and energy lose all ability to interact. Stars burn out. Black holes evaporate. Particles decay. Temperature drifts toward absolute zero. Motion ceases. Time loses meaning. The cosmos becomes an endless, cold plane of nothingness stretching forever. This is not destruction. It is dissolution, the fading of all structure, all memory, all light. A universe where even thought becomes impossible. A cosmic winter that never ends. But the heat death is only one fate. There is another, more violent possibility, the Big Rip. In the Big Rip scenario, the same mysterious force causing the universe's expansion, dark energy, continues to grow stronger. Over billions of years, its repulsive pressure intensifies until it begins tearing apart galaxy clusters, then galaxies, then star systems, then planets, then atoms. Even the smallest particles are shredded by the accelerating expansion of space. The universe doesn't just end. It is ripped apart from within. If dark energy continues to evolve in the wrong direction, the Big Rip is inevitable. The cosmos becomes a battlefield between expansion and existence, and expansion wins. But there is a third possibility, stranger and more cyclical: the Big Crunch, or its modern counterpart, the Big Bounce. In this destiny, the expansion eventually slows. Gravity reasserts itself. Galaxies draw closer. Stars collide. The universe contracts, folding inward like a collapsing lung. Temperature rises to impossible extremes. Matter compresses into a dense, searing core. At the final moment, everything, every particle, every atom, every galaxy, is crushed into a single point. From that point, a new universe might explode outward. A rebirth. A cosmic reincarnation. Perhaps our universe is not the first. Perhaps it is one of countless cycles. A universe born from the ashes of a previous reality, inheriting subtle scars in its cosmic microwave background. If this is true, then the universe carries memories of ancient collapses, imprinted in patterns we have yet to decode. And yet, something feels strange. None of these endings fully explain the anomalies we observe. None of them account for the delicate tuning of cosmic constants. None explain why dark energy changed strength billions of years after the Big Bang. None explain why time flows forward instead of collapsing into chaos. There are other theories, darker ones, that whisper of hidden mechanisms guiding the universe toward a fate more calculated than chaotic. Some physicists propose that the universe may not naturally expand forever. They imagine a hidden transition, a shift in the vacuum state, that could reset the laws of physics suddenly. If a lower energy vacuum emerges somewhere in the universe, it will expand outward at the speed of light, rewriting everything it touches. This vacuum decay would not produce sound, light, or heat. It would be a silent wave of annihilation. One moment, atoms hold together. The next, the universe adopts a new rulebook. And nothing remains of the reality that came before. This possibility is terrifying because it offers no warning, no escape, no hope. It is not an ending chosen by fate but triggered by the fundamental instability of the universe's current state. Some theories suggest that such transitions have happened before, that earlier universes may have dissolved into new phases, leaving behind subtle scars in cosmic structure. These scars may be visible in the strange cold regions, the mismatched fluctuations, the unexplained asymmetries in the cosmic microwave background. Perhaps they are echoes, faint fingerprints, of past universal deaths. Yet another theory suggests the universe may not end from the outside or the inside, but from the accumulated actions of intelligence itself. Imagine civilizations billions of years more advanced than ours. Imagine beings capable of manipulating dark energy, generating artificial black holes, or altering cosmic fields. Their attempts to survive could influence the trajectory of the universe. Their experiments might destabilize spacetime. Their technologies might trigger catastrophic transitions. If intelligence becomes widespread enough, it may act like a cosmic infection, spreading through galaxies, devouring matter, reshaping space, and ultimately overwhelming the universe's natural processes. In such a scenario, the universe ends not because physics demands it, but because life accelerates it. But the most unsettling fate is one almost never discussed outside theoretical circles: the possibility that the universe may be erased by something outside it. If our universe is a bubble in a larger multiverse, as some theories suggest, then pressure from surrounding universes could eventually overwhelm it. A collision, a boundary shift, an energy imbalance, any of these could trigger a catastrophic breach in spacetime. The structure holding our universe together could fail, collapsing inward as higher dimensional forces rush in. The universe would not merely collapse. It would be overwritten. Replaced by a new physics, a new geometry, a new reality. All stars. All galaxies. All memories. All history. Gone, not gradually but instantly. Yet through all these possibilities, one truth becomes clear: the fate of the universe is not simple. It is not predetermined. It is not gentle. The universe is filled with forces we barely comprehend. Dark energy pushing everything apart, black holes devouring information, quantum fields trembling beneath spacetime. These forces are interacting, evolving, competing. The universe may not be drifting toward one fate. It may be choosing among many. Every moment that passes, every spark of creation, every collapse of a star, every ripple of gravity, is writing the final chapters of existence. What we observe today, the acceleration of space, the thinning of the cosmic web, the eerie silence of the universe, may be early signs of its chosen destiny. Perhaps the universe is winding down. Perhaps it is gearing up. Perhaps it is preparing for transformation. We do not yet know the final ending. But one thing is certain, the universe is not static. It is evolving. It is moving toward a fate written in the hidden code of its own creation. And that fate may already be unfolding. Before the Big Bang there was silence. Not the silence of empty space, but the silence of something that had no time, no matter, no dimension. A silence that was total because nothing yet existed to break it. And yet, within that nothingness, something stirred. The universe did not simply appear. It erupted, as if awakening from a dream that left behind no memories except faint, inexplicable traces woven into the structure of reality. These traces hint at eras far older than the one we inhabit. Lost epochs, forgotten cycles, and cosmic histories buried beneath the surface of spacetime itself. Imagine the Big Bang as not the ultimate beginning, but merely a doorway, an explosion marking the end of one universe and the birth of another. If our universe is only the latest chapter in a much older story, then the remnants of previous universes may still linger around us, encoded in patterns we struggle to decipher. Even the cosmic microwave background, the afterglow of creation, contains anomalies, scars, cold regions, and unexplained circles that do not fit the predictions of a universe born clean and untouched. These anomalies behave like fingerprints of ancient events. They whisper that something existed before the dawn of our cosmic expansion, something powerful enough to leave its mark on the newborn fabric of space. Consider the idea of a cosmic cycle, universes expanding, collapsing, and rebirthing across incomprehensible time scales. In each cycle, the laws of physics might shift slightly, geometry might alter subtly, and matter might reorganize into unfamiliar structures. These cycles could stretch back infinitely, each producing its own galaxies, black holes, and civilizations. If so, our universe is not a singular miracle but the latest bloom in an endless, cosmic forest. And if cycles exist, then memory exists. Not memory as we understand it, no journals, no fossils, no spoken stories, but memory etched into cosmic patterns, gravitational echoes, temperature variations, quantum imprints, and anomalous alignments. These are the fossils of universes long vanished. Now imagine traveling back before our Big Bang. Instead of nothingness, you find a universe contracting, galaxies collapsing inward, stars merging, black holes consuming the remnants of time. Space shrinks. Temperature rises. The cosmic structure crushes into a dense, fiery core. Yet inside that core information remains. The universe compresses itself into a seed of pure potential. And then, in a moment that defies human language, the seed explodes outward, not from zero but from the ruins of what came before. Some physicists argue that the universe retains traces of this prior existence in the form of gravitational waves older than spacetime itself. These waves would be faint, almost ghost-like, vibrating at frequencies so low they slip beneath the threshold of our instruments. But they might be there, moving silently through galaxies, carrying messages from a universe that died so ours could be born. But what if the pre-Big Bang universe was not a collapsed version of ours? What if it was entirely different, governed by alternate physics, different dimensions, strange forms of matter, and life unimaginable to us? In that case, the transition between universes wasn't a collapse, but a metamorphosis, a transformation. Picture a cosmic chrysalis, a universe ending not in destruction, but in evolution, reshaping itself into something new. Our Big Bang could have been the moment that transformation completed, the moment a prior universe shed its form and gave birth to this one. If this is true, then our universe inherits traits from its predecessor. Much like a child inherits genetic memory, the cosmos may inherit structural memory, patterns that reappear not because of chance, but because they were built into the previous universe's fabric. Some researchers believe that black holes are the key. When a black hole forms, it collapses matter into a singularity, a point of infinite density. Many theorists suspect that these singularities might become the seeds of new universes, budding off from the old through dimensional cracks. If so, then every universe could give birth to countless offspring, each inheriting subtle physical characteristics from its parent. In this view, our universe may be just one leaf on a vast family tree of realities, a lineage stretching back beyond imagination. But what if something survived the transition? Not matter, not energy, but patterns that could influence the evolution of new universes. Perhaps these patterns are responsible for the fine-tuning of physical constants. Perhaps they guide the formation of cosmic structures. Or perhaps, in ways we cannot yet comprehend, they encode information. Information that flows across the boundaries between collapsing and expanding universes. Imagine a form of memory that survives cosmic death. Imagine knowledge passed from universe to universe. Imagine intelligence that persists not through biology but through physics itself. Some theories suggest that consciousness might have originated before the Big Bang, not in brains or bodies but in the quantum fields of a previous cosmos. If awareness can arise from complex patterns, then perhaps consciousness is older than our universe, carried forward through the collapse, emerging again as matter reorganizes itself. Other theories propose that the universe might be learning, evolving across cycles, shaping itself into forms increasingly capable of complexity, structure, and life. In that case, the universe is not random. It is not accidental. It is guided by something we do not understand, a hidden process connecting present reality to ancient eras that existed before time began. Now imagine the remnants of previous universes as cosmic ruins, gravitational scars, anomalous alignments, unexplained structures embedded in the cosmic web. These ruins might be the last signatures of civilizations that lived before our universe existed, civilizations erased not by war or extinction, but by the collapse of their entire reality. What if they left messages encoded in physics itself? What if they attempted to influence the next universe? What if they succeeded? The idea is humbling, terrifying, and awe-inspiring. True, our universe is not isolated. It is part of a lineage, a continuum, a chain of existence stretching across dimensions and eons. And if the universe has memory, then we are living inside a story much older than we can comprehend, a story whose earliest chapters have been burned, shattered, reborn, and written again across the canvas of expanding space. The Big Bang was not the beginning. It was a turning page. One page in an ancient book with many missing chapters, chapters carved into the hidden mathematics of reality, waiting for us to uncover their meaning. The universe we see is only the latest version. And beneath its surface, shadows of older universes still whisper. Reality, for all its beauty and complexity, rests on a precarious foundation, a delicate balance of quantum fields that define the laws of physics. Everything you see, everything you touch, every star that burns and every atom that binds together exists because the vacuum of our universe settled into a stable configuration after the Big Bang. But stable does not mean permanent. Beneath the surface of existence lies a terrifying possibility. The vacuum state we live in may not be the true ground state of the universe. It may be temporary, a metastable plateau perched above a deeper, more stable vacuum. If that deeper state ever forms, reality would collapse in an instant. This collapse is called vacuum decay, and it is one of the most chilling phenomena physicists can imagine. Unlike supernovas, black holes, or gamma-ray bursts, which can at least be predicted or observed, vacuum decay gives no warning. It begins with the sudden appearance of a tiny bubble, smaller than an atom, where the laws of physics shift into a lower energy configuration. This bubble then expands at the speed of light, rewriting everything in its path. Inside the bubble, physics itself changes. Constants shift. Forces behave differently. Atoms no longer hold together. Chemistry collapses. Matter dissolves. Space and time warp into unfamiliar shapes. The universe as we know it ceases to exist, instantly replaced by something new, something alien, something utterly incompatible with our reality. Because the bubble moves at light speed, no one would see it coming. One moment you would be alive. The next, the fabric of reality itself would have been overwritten. The most terrifying part is that we cannot stop it. We cannot predict it. We cannot survive it. Now imagine that such vacuum decay events might have occurred before, in other regions of the cosmos, in other universes, or in other epochs of reality. Their scars might remain in the form of unexplained cold regions, warped spacetime pockets, or cosmic voids with strangely smooth boundaries. Perhaps those regions are not empty at all, but dead, remnants of universes that transitioned into new states while ours survived. Some theoretical models predict that regions of pre-existing vacuum decay might appear as spherical imprints on the cosmic microwave background, faint circular anomalies frozen in ancient light. Some of those anomalies have been detected. They do not fit the expected statistical patterns. They are too defined, too clean, too purposeful. It is possible that we are looking at the graves of other vacuum states, destroyed realities whose transitions brushed against ours billions of years ago. Imagine those bubbles expanding across a primordial multiverse, colliding with each other like waves merging in an ocean. Each bubble carving out a new physics, a new geometry, a new reality. Our universe might be one such bubble, and its current stability may only be temporary. The next bubble could already be forming somewhere in our cosmic horizon. But what triggers vacuum decay? What force could ignite such a catastrophic transformation? Some physicists believe that quantum fluctuations, the restless stirrings of the vacuum, could spontaneously form a bubble of lower energy vacuum. Such fluctuations occur everywhere all the time, though most are harmless. But a rare, massive fluctuation could push the vacuum over the edge, igniting the collapse of reality. Others suggest that extreme conditions, such as collisions of massive black holes or the energies near singularities, might destabilize the vacuum. In this terrifying vision, the universe becomes more dangerous as it ages, as massive structures collide, merge, and evolve. More unsettling still is the idea that vacuum decay could be triggered artificially. If a civilization ever became advanced enough to manipulate quantum fields on colossal scales, their experiments might accidentally, or intentionally, destabilize the vacuum. A single mistake in a high-energy reaction could rewrite the cosmos. A weapon capable of manipulating spacetime could trigger a collapse that spreads across the universe. Even our own accelerators, though far too weak to pose a risk, hint at technologies that future civilizations might wield with catastrophic consequences. But perhaps the most disturbing idea is that vacuum decay is not random at all. Some theorists propose that the universe may be heading toward vacuum decay by design, not accident. In this view, our vacuum is inherently unstable, a temporary home meant to evolve into a more fundamental state. The universe may be preparing itself for a phase transition on a cosmic scale, a transformation as natural as water freezing or boiling. In this scenario, vacuum decay is not a threat. It is destiny. The universe may already be experiencing subtle signs of this transition. A dark energy accelerating expansion, as strange anomalies in quantum fields, unexplained distortions in spacetime, hidden inconsistencies in particle behavior, and the apparent fine-tuning of physical constants. Perhaps the laws of physics are shifting, slowly, silently, preparing for a final transformation. And then there is the possibility that vacuum decay has intelligence behind it. If universes can transition into more stable states, and if some universes survive longer or produce more structure than others, then a natural selection process might occur across the multiverse. Vacuum states that support complexity might propagate. Others that collapse immediately might vanish. Over countless cycles, the multiverse could evolve to favor universes where vacuum decay occurs at precisely the right times and conditions. In this vision, vacuum decay is not a catastrophe. It is part of a cosmic evolutionary algorithm, a mechanism selecting for universes capable of producing complexity, structure, and perhaps consciousness. But what if something else is selecting these transitions? Something beyond our understanding? Imagine beings existing not in spacetime, but in the quantum fields beneath it. Entities composed of field fluctuations, patterns of energy, or higher dimensional geometries. These beings might perceive vacuum decay not as destruction, but as transformation. They might even engineer transitions across universes, guiding the evolution of reality for purposes unknown. If such entities exist, then vacuum decay is not random noise. It is communication. A cosmic message written in the language of physics. A rewriting of existence. And if vacuum decay has occurred in other universes, if bubbles collide, merge, or influence each other, then the signatures of these transitions may be woven into our universe's architecture. Strange cold regions. Sudden gravitational anomalies. Inexplicable alignments. These could be the fingerprints of past events, echoes of collapsing realities pressed against the edges of our own. But the most terrifying possibility is also the simplest. Vacuum decay may already be happening. A bubble could have formed billions of light years away, expanding outward at the speed of light. We would not detect it until it reaches us. The collapse could be moments away or trillions of years in the future. The universe gives no clues. And yet, humanity continues to search, to understand, to decipher the laws that hold us in place. Perhaps knowledge is our only defense, not against vacuum decay itself, but against the terror of the unknown. Because if the universe can end without warning, then the meaning of existence must lie elsewhere, not in permanence but in awareness. In the fragile miracle of being alive inside a reality that could vanish at any moment. The universe is a fragile bubble floating in a sea of deeper possibility. And beneath its shimmering surface, something ancient is stirring. Beneath every star, every atom, and every breath of existence lies an invisible framework, a hidden architecture shaping reality from below. We live inside its surface layer, unaware that the true foundation of the universe may exist far deeper than matter or energy. When physicists peel back the layers of nature, they find an elegant structure that behaves less like chaos and more like a design system. At its core, reality appears mathematical. Particles behave like solutions. Forces follow equations that seem too precise to be accidental. It is as though the universe is built from patterns, not objects, patterns emerging from a deeper scaffold that cannot be seen directly. Some theories describe this scaffold as a network of tiny units, like pixels forming space itself. Others imagine vibrating strings whose frequencies generate every particle. Some propose that we live on a brain floating in a higher dimensional realm, with gravity leaking into other dimensions like water slipping through cracks. In all these visions, our universe is not the whole story, it is a projection, a shadow of a more complex structure. If spacetime is made of threads, then reality is a woven fabric. If those threads shift, the laws of physics shift with them. Perhaps constants remain stable because deeper rules hold them in place, like an operating system maintaining order in a machine. This architecture may adapt, self-correct, or evolve over time. But what if it does more than stabilize? What if it watches itself? Consciousness may not be separate from this structure but an emergent property of it. Minds might be temporary patterns woven into the deeper code, reflections of the universe examining its own foundation. The architecture is everywhere, shaping every moment, and we are living inside its unseen design. Imagine reality as a flawless stage where every law, gravity, light, time itself, performs with perfect consistency. Yet beneath that perfection lies an unsettling possibility. The universe might not be a natural structure at all, but a constructed system. A simulation. A coded environment designed with boundaries, safeguards, and rules that feel ancient only because we have never seen them change. When physicists zoom into the smallest scales, they do not find smoothness. They find discreteness, as though space and time come in indivisible units, pixels of the cosmos. Particles behave like information packets rather than physical objects. Forces act like algorithms. Even the speed of light resembles a maximum data transfer rate, a cosmic speed limit enforced by the system. Quantum entanglement behaves as if the underlying program simply updates states simultaneously, ignoring distance. Dark matter and dark energy act like scaffolding, shaping the universe the way invisible code shapes a digital world. The laws of nature are too perfect, too fine-tuned, almost suspiciously optimized for stability and complexity. What if the universe allocates more processing power as it grows, causing the expansion we mistakenly call dark energy? What if consciousness itself is not a biological accident but an emergent property of information, a feature of the simulation's architecture? Occasional anomalies, strange cosmic readings, impossible particle behavior, abrupt shifts in quantum probabilities, might be glitches or updates. Perhaps the system recalibrates itself as we probe deeper. Perhaps the universe reacts to observation. And if this world is a simulation, then nothing is permanent. Everything, space, time, matter, memory, could be rewritten. The universe might not end in destruction but in an update, or a shutdown. Across every mystery we've explored, dark matter, hidden voids, strange cosmic alignments, quantum anomalies, one question emerges like a dark shape behind a veil. What is the universe trying to conceal? Each phenomenon seems isolated, yet they all point toward an unspoken connection, as though reality is stitched together with secrets too dangerous or too immense for human minds to hold. Imagine the cosmos as a labyrinth where every discovery illuminates not certainty, but larger shadows. The universe behaves less like an accident and more like a system, a mechanism with boundaries and protections. The fine-tuning of physical constants feels intentional. Quantum behavior shifts under observation. Cosmic structures align across billions of light-years. None of it seems random. Does the universe want to be understood? Or does it want to remain hidden? Perhaps intelligence is not an evolutionary accident but an inevitable byproduct of the universe's design, a feature meant to observe, to question, to interact with whatever lies beneath. But what if this curiosity brings risk? What if the universe has defenses, triggered when awareness digs too deeply? Look at the clues. Sudden anomalies appearing only when instruments grow sensitive, forbidden regions behaving like protected zones, unexplained distortions emerging at the edges of observation. These could be reactions, the universe subtly pushing back. Which leads to the question humanity was never meant to ask. Is the universe conscious? Not conscious like a mind, but conscious as a distributed awareness woven through spacetime. If every observation is noticed, if every breakthrough is a signal, then we are knocking on a cosmic door without knowing what stands behind it. The final question is not what the universe is. It is why it is hiding something at all, and what happens when we finally uncover it.